Hello, this is Jeffrey Fox, and we're coming now to the second unit on e-commerce and what I call lifestyle informatics. And we're going to go into a little more detail on what a recommender system is. And of course, as always, we're using clouds. That's where our recommender systems run. Data analytics is recommender systems. We'll be doing it collaboratively, and we're processing enormous amounts of big data, user rankings, and things like that. And we're solving problems here in lifestyle informatics. And here's our nice collage. And first, we start with a little bit of recap from the previous unit. And this is roughly the same slide as one was present in the previous unit. But I think it summarizes what we're trying to do extremely well. We're matching items, which includes people to people, or collections of items to collections of people. And the examples we have are people to products, that's online and offline commerce, people to people, that's social networking, Facebook, um, LinkedIn, and so on. We have people to jobs or employers, that's job sites, Career Builder, and Monster. And people plus the queries that people make to the web. That's information retrieval or web search, which we'll discuss as a separate major use case later on in this course. And then recommendation systems or recommender systems help in the match of the users with the items. And they both provide information overload reduction, because otherwise there's no way you can go through all the information, especially as we learned with the long tail. These online sites have many more items than, say, a traditional shop would have, a brick and mortar shop. And in some sense, this is automated sales systems, because they're telling you guidance, they're advising you, and in some sense, they're persuading you, because they will sometimes actually make ingenious um, reduction in prices to try to entice you to buy something they really think you might like. When we go to Wikipedia, it has a nice, under the recommender system uh, unit. We have some nice examples like uh, Amazon.com, which uses user-based collaborative filtering by looking at the other shoppers which brought the item you just got, and see what other things they purchased. Um, Pandora is on a different type of approach. It uses the property of the song or the artist, which is captured in the so-called music genome, which characterizes the different songs, and they try to build a station that plays music with the similar properties, assuming that what you've listened to is a characteristic of what you like. And then you feedback as to whether they made a good choice or not, and then they adapt this algorithm. So this is property-based recommender system, and they basically try to weight the different attributes to optimize the chance they'll make a good prediction. So this is called content or property-based recommender system. Um, Last.fm does this in a different way, which is nearer the way Amazon does. And it just looks at what tracks and bands the users listen to, and comparing that with the listening behavior of other users. That's like the buying behavior that Amazon uses. And they will play tracks that don't appear in your library, but are just played by other users with similar interests. That's the basic idea of these things. You either take an item, find other items near it based on the recommendations or the purchase habits of other users, or they find other users that look like you in terms of things that you've done, and then see what those other users have done. And Netflix is similar, except it has a larger entity than probably Last.fm and Pandora. It does in a far more sophisticated fashion, which takes account both properties, because it wants to give so-called diversity, so that it gives you many different types of movies to look at, as well as the recommender system idea. So in the next lesson, we'll look at a couple of examples of recommender systems, Google News, and sort of more brick and mortar type approach of how to decide what to put on sale and when um, in the in making brick and mortar shops successful. I know that even if you have a brick and mortar shop, you actually need to use very sophisticated analytics to decide how best to stock that shop. And the shops that haven't done that are succeeding not and do not succeed as well as the shops that have. Thank you very much. Let's get on with the next lesson.